Hello learners, welcome back to my channel Shraddha's Physics. In this part we will see the expansion with the arbitrary period in Fourier series for even and odd function. Now let us first calculate for the even function. That is, if I will consider the function f of x, let me write the function f of x in the interval, that is the arbitrary interval minus L to plus L, and here we have considered the even function. This is your even function, that is f of x is an even function within the interval minus L to L, such that we can say that since it is an even function, we can write f of minus x, that is equal to f of x, since it is an even function. Now we can write the coefficient. Okay, so the coefficient we know a naught equal to 1 by 12, that is in the arbitrary period we can write 1 by 12 integration from minus L to plus L f of x dx. And since here it is an even function, we know from the previous class that you can calculate the even function when it lies between the integration value minus L to plus L, that will simply changes to twice of 0 to L. So from the past lecture we have already discussed these things. If you have not watched that video, just try to watch that. Okay, since it is an even function in the properties of the Fourier series, so we have already discussed this topic. Okay, since it is from minus L to plus L, so for the even function we have to consider this to be twice of 0 to L. So now we can write this as this is equal to 1 by 12 into twice of 0 to L f of x dx. So simply cancelling this 2 with this 2, so the a naught value will be equal to, that is a coefficient we can write, that is equal to 1 by L integration from 0 to L f of x dx. Okay, and now also we can calculate for an. Now we know an equal to, for the arbitrary period we can write this is equal to 1 by L integration from minus L to plus L, this is f of x into cosine n pi x divided by L into dx. So here you can see that the function we have taken, this one is your even, as well as cosine function is also even. The even with the even function, when we will take the product, you will always get an even function. So now since this is also an even function, we can directly write the even function integration will be equal to twice of 0, this is your 2 by L, let me write, integration value changes from 0 to L f of x, this will be cosine n pi x by L, this is n pi x divided by L into dx. Okay, now similarly if I will calculate for Bn, so you know Bn equal to, for the arbitrary period 1 by L integration from minus L to plus L, this is f of x sine n pi x divided by L into dx. I hope you remember this, because this is your previous class part. You can see from the previous lecture we have already discussed that for the arbitrary period you have to consider this Fourier series will be equal to this much, the function of the Fourier series, and these are the Fourier coefficients, that is a naught, a and bn. So now from that we can write, so this bn value equal to this much, you know. So now if we substitute this, you know this is an even function, and this sine function, it is an odd function. When you multiply even with the odd, you will always get an odd function, and the odd function integration will always give rise to your 0. So this bn value goes to 0, only a naught and an value exist. Now if I write the Fourier series for the even function, then this f of x will be equal to a naught plus sum over n equal to 1 to infinite, this will be your an cos n pi x by L. Okay, so this is known as, so this Fourier series is known as Fourier cosine series, since this is for your even function we have considered. So this is called the Fourier cosine series, or also it is known as, or this is half range cosine series, half range cosine series. Okay, so basically we can say that if the function is even, So we can calculate its series, Fourier series, as well as its coefficient. Only a naught and a n exist, but the b n coefficient goes to 0. Okay. Now we will calculate for the odd function. Now here we will consider the function to be odd. So let us consider the function that is your odd function. Let me write. Let us consider an odd function. Suppose f of x, and it is defined in the interval minus L to plus L. So the function is defined in the interval minus L to plus L. Since this function is odd, I can write f of minus x, that is equal to minus f of x. Since the function is odd, we can write this. Now the coefficients of the Fourier, that is a naught, we can write equal to 1 by 12 integration from minus L to plus L f of x dx. That is for the arbitrary period. We have to write the Fourier coefficient like this. And here we have considered this function is odd. So when the function is odd and its limit varies from minus L to plus L, so this integration goes to 0. When the function is for the odd function integration, this goes to 0. Now if I calculate the value of a n, that is equal to 1 by L integration from minus L to plus L, this is f of x sine n pi x divided by L into dx. And here you can see this is your cosine n pi x by L. This a n, this is your, let me just erase this one. For b n this will be sine. For a n I am writing here cosine n pi x by L. So here this function is odd function. We have considered initially that function, this is your odd function. So this one is your odd function, and cosine function, it is an even function. When you multiply odd with the even, you will always get an odd function. And again this odd function, when it integration varies from minus L to plus L, its value goes to 0. Okay. Now we can calculate the coefficient bn, that is equal to 1 by L integration from minus L to plus L f of x sine n by x by L divided by into dx. Here it is the odd function, and this one is also the odd function. So odd into odd, it will give the even function. Now if I will calculate, this will be equal to 1 by L. So this will be twice of L. So this will be twice 2 divided by L integration from 0 to L. Since you know for the even function you can change minus L to plus L to the interval 2 into 0 to L integration. So this will be simply f of x sine n pi x by L into dx. Okay. Now if I will write the Fourier series, that is f of x. So here when you consider the function to be odd, so here a naught and a n term goes to 0. So here we can write the coefficient for b n only. So that is equal to sum over n equal to 1 to infinite b n sine n pi x by L, since other term goes to 0. Okay. So this is the Fourier series expansion for the odd function. So this is called the Fourier sine series, Fourier sine series, or this is also known as half range sine series, or this is also known as half range sine series. Okay. So in this way you can calculate for even function the Fourier series, and for the odd function the Fourier series for the arbitrary interval, that is from minus L to plus L. So you can see here from this expression, you can see when the function is even, for the even function only a naught and a n exists, b n goes to 0 when the function is even. But when the function is odd, only b n exists, other a naught is 0 and a n equal to 0. So this is the basic difference between for the even function and for the odd function. Now let us take an example. Suppose in a question it is given, you have to calculate f of x equal to, suppose f of minus x for the interval minus L less than x less than 0. That is when x lies between minus L to 0, its value is f of minus x, and its value will be f of x when x lies in the interval 0 to L. And the another one is the function goes to 0 otherwise. So let me write another question. So the function is f of x will be equal to f of, this is minus f of x, let me write, this is minus f of x when x lies between minus L to 0, and this is minus L to 0, let me simply write, and its value will be equal to f of x when x lies between 0 to L and 0 otherwise. Okay, so now from these two questions, now you will just think which one will be the Fourier cosine series and which one will be the Fourier sine series, or the even series or the odd series you may say. Now just think about this first question. We have already discussed that when f of minus x equal to f of x, then in that case we can say the function is even, and when f of minus x equal to minus f of x, then that function is called the odd function. Now you have to check when this interval lies between minus L to 0, x lies between. In this interval the function is f of minus x, which is equal to f of x, and the function value will be f of x when x lies between 0 and L. So here you can see that f of minus x equal to f of x simply. Since f of x equal to this much as well as this much, so simply we can say this f of minus x will be f of x at a point. So there must exist a point, that is, suppose I may say at this 0 point, I may say that the function f of minus x will be equal to f of x. When this condition satisfies f of minus x equal to f of x, so we can consider the function to be even. So when the function is even, I can say that this will be your Fourier cosine series. This is your Fourier cosine series. Now similarly for the second one, you can see f of x equal to minus f of x when it lies between minus L to 0, and here when x lies between 0 to L, the function value goes to f of x. So for suppose any point is 0, I can consider this f of x equal to minus f of x as well as f of x equal to f of x. So simply I can write this f of x equal to minus f of x. So when I can write, so this is f of minus x. Okay, since it lies between minus L to 0, and this is your f of minus x. So from this expression you can see, since f of minus x equal to minus f of x is odd, that is the function we have considered. So here you can see, so let us consider this example. In this interval, that is minus L to 0, the function goes to minus of this much. Okay, the function goes to minus of f of x. But originally in this interval the value is 0 to L. Within this interval the function value is f of x. Since when the interval, that is this negative minus L, will change to plus L, then in that case this minus f of x will changes to f of x. Okay, so simply we can say that this will be possible for the odd function. So this, when this will be the odd function, we can say that this will be Fourier sine series. Okay, so the direct question you can get in your exam, that is you have to choose which one will be the Fourier cosine series and which one will be the Fourier sine series. Okay, so this is all for today. Still, if you have any doubt, can ask me in the comment section. Thank you all.